If we don't have the new strategy for this one, it becomes impossible. Because our main strategy was change everything to sine and cos. Oh, that's already done. And then it was like, oh, can you get both sides to be a single fraction? And both sides are already a single fraction. So the first strategy that we like to use is completely useless. It's already done for us, and the question isn't done. Now we have sine squared theta plus cos squared theta equals 1. But that's not allowed because we have nothing squared. So we're really stuck. Okay? And the strategy that we're going to use, I like to call it build the other side. I like to call it this because it gives you a hint what you should do. If you remember the strategy name, build the other side, it gives you a hint of what you should do. The strategy is typically called multiply by the conjugate, but most of us forget what the word conjugate means in mathematics. So because we use a math word that we don't know what it means, it's very hard for us to use that strategy to help us. Because we're like, I'm supposed to do something with something that I don't know what it is, I'm stuck. So what does build the other side strategy mean? Build the other side strategy says, in mathematics, or in these proofs, we're allowed to multiply by 1. Multiplying by 1 changes what a fraction looks like, right? Because 1 over 2 is the same as 3 over 6. And you get them to be the same by multiplying by 3 over 3. You're multiplying by 1. When you multiply by 1, you change what a fraction looks like, but you don't change what it's equal to. And what the build the other side strategy says is if things aren't working for you, maybe if you make something the same, it would help. And you can either make your denominators the same or your numerators the same. So I'm going to make my denominators the same. This denominator on the left-hand side is sine theta. So on the right-hand side, I'm going to put a sine theta on the bottom. But if I put a sine theta on the bottom, I would also need a sine theta on the top. And on the left-hand side, if I want my denominators to be the same, it's missing a 1 plus cos theta. So I multiply the bottom by 1 plus cos theta and the top by 1 plus cos theta. Okay. Why is this helpful? Well, we'll see. At least by doing this, my denominators are going to be the same, and I'm going to leave them factored. I'm not even going to multiply them out and risk making a mistake. I can just leave it factored. My denominators are the same. What happens in my numerators? On the right-hand side, I have sine theta times sine theta, which gives me sine squared theta. And on the left-hand side, I have 1 plus cos theta multiplied by 1 minus cos theta. That's a difference of squares. Difference of squares will give me 1 minus cos squared theta. So to build the other side strategy, at least my denominators are the same. So now all I would have to do is get my numerators the same, and now I have things that are squared. So I'm allowed to use sine squared theta plus cos squared theta equals 1. One mental math manipulation. You could get 1 minus cos squared theta all by itself, and it would equal sine squared theta. And our proof is done. So on our strategies page, if you turn back to page 620, I'm going to number these a little bit. Number one is a main strategy, probably the thing you look for most. Should I change things to sine and cosine? Can I add, subtract, simplify fractions to get a single fraction on the other side? Then strategy number two is to look for, if you have a sine squared, a tan squared, a cotangent squared, a cosecant squared, anything squared, or if you have the number 1, probably you have one of those three identities, because they all involve 1s, and they all involve something squared. So I listed as strategy 2, but you should look for it right away, because often it can make your proof quicker than doing strategy number 1. Strategy number 1 is a good strategy, works most of the time, but sometimes it's not the quickest strategy. Then what we just saw, the build the other side, is the same as multiplying by the conjugate. It's the same thing, but one uses a word that you forget. What is a conjugate in math? Well, the conjugate of x plus 3, the conjugate is the same thing with the different sign in the middle. It's what comes together to make a difference of squares. So it's very connected to a difference of squares strategy. And this one that I'm not going to put anything beside, you always be aware of the other side, is just a common idea. Like, look on both sides, see which of the strategies you think is going to help you the most. The ones with a star is what you have to remember factoring and building the other side, because that's when you're going to get stuck. And so you need to have a little person on your shoulder saying, hey, when I get stuck, think of those ones. Because you will get stuck. And then you're going to come to me and say, I'm stuck. And then I'm going to say, what did I tell you to do when you get stuck? And then you're going to say, I don't remember. And I'm like, oh, you have to either build the other side or factor. Oh, yeah. You remember now. That's why you need a little tiny little person on your shoulder that can tell you that. When I get stuck, factor, build the other side. So let's look at the second one. Okay. I see something squared. So I might be like, oh, I'm going to hold off on the right-hand side, because maybe I want to use my formula for that. I look at the left side. It's in cos already. It's 2 fractions. So I would definitely go with, I need to combine that as a single fraction. How do you combine things as a single fraction? You need a common denominator. So, what would be my common denominator? This one needs to be multiplied by 1 plus cos theta and 1 plus cos theta. This one is going to need to be multiplied by 1 minus cos theta and 1 minus cos theta. That makes a difference of squares, because those are conjugates on the bottom. My bottom is going to be 1 minus cos squared theta. And on the top, I would have 1 plus cos theta plus 1 minus cos theta, which nicely comes out to a 2 on the top. Okay? Since my left-hand side has no cotangents, I probably, here, I'll just rewrite this for a second, so I don't forget that. Since there's no cotangents on the left-hand side, when looking at cosecant squared, because of that, I would decide to change it to 1 over sine squared. And 2 times cosecant squared is 2 times 1 over sine squared. How do I multiply fractions? I multiply just the tops, and I multiply the bottoms. I'm so close. My numerators are already the same. I just have to figure out a way to change my denominators to be the same. And can you see from sine squared theta plus cos squared theta equals 1? One mental math manipulation, and this is equal to sine squared theta. QED. You can circle 12A, and with those new strategies, the proof sheet that I gave you at the beginning, you can now go all the way up to like 45 or 46. Basically all of them. I think there's only 1 or 2 on there that I would expect you not to do.